Elon Musk has famously stated that there's a 1 in a billion chance we're living in base reality. It's a mind-bending idea that has moved from science fiction to serious academic and scientific discussion. What if our entire universe, everything we see, feel, and experience, is nothing more than an incredibly advanced computer simulation? Let's explore the scientific arguments that give this astonishing theory some weight. The core idea of simulation theory isn't new. Philosophers have long questioned the nature of reality. Plato's allegory of the cave, for example, imagined prisoners who mistake shadows on a wall for the real world. But today's version, popularized by philosopher Nick Bostrom, is rooted in logic and technology. Bostrom's simulation argument presents a trilemma, a set of 3 possibilities, one of which he argues must be true. The first possibility is that civilizations like ours almost always go extinct before they can develop the technology to create ancestor simulations, which are highly detailed simulations of their past. The second is that advanced civilizations, for some reason, lose all interest in creating such simulations. Perhaps there are ethical prohibitions, or they simply find other things more compelling. The third possibility is that we are almost certainly living inside one of these simulations. If you think about it, if a civilization can create simulations, they won't just create one. They would likely create thousands, or even millions. This means the number of simulated realities would vastly outnumber the one and only base reality. Therefore, statistically speaking, it's far more probable that we are in one of the many simulations rather than the single original universe. It's a game of numbers, and the numbers don't seem to be on the side of base reality. Now, let's look at the evidence from our own world that seems to support this idea. One of the most compelling arguments comes from the world of quantum physics, the study of the universe at its smallest and most bizarre scales. In the quantum realm, particles like electrons don't seem to have definite properties until they are observed. This is the famous observer effect. A particle can exist in a superposition of multiple states at once, like a spinning coin that's both heads and tails simultaneously. Only when we measure it does it choose a state. This is strikingly similar to how a video game renders its graphics. A game doesn't render the entire world all at once down to the last detail. That would take an impossible amount of computing power. Instead, it only renders what the player is currently looking at. The tree behind you only pops into full detailed existence when you turn around to look at it. Could our reality be working on the same principle of computational efficiency? Is the universe only rendering the details when a conscious observer, like one of us, is there to see them? Another piece of the puzzle is the fact that our universe appears to be pixelated. There seems to be a fundamental limit to how small things can get. The Planck length, about 1.6 x 10 to 35 meters, is thought to be the smallest possible unit of distance in the universe. You can't have half a Planck length, just as you can't have half a pixel on a screen. If the universe were continuous and infinite, we wouldn't expect to find such a fundamental, indivisible unit. But if it's a simulation, having a minimum resolution, a pixel size, makes perfect sense. It's the smallest bit of information the system can handle. This concept suggests that space-time isn't a smooth, continuous fabric, but a grid-like structure made of these discrete units. Much like the pixels that form the images on our screens, then there's the matter of the universe's rules. Our universe is governed by a set of precise and unchanging mathematical laws. The speed of light is a constant, a universal speed limit that nothing with mass can exceed. The force of gravity has a specific strength. These fundamental constants seem finely tuned for life to exist. If they were even slightly different, the universe would be a sterile, empty place. This fine-tuning problem has long puzzled physicists. Why are the laws so perfect? One explanation is the simulation hypothesis. If a programmer were to design a universe, they would have to set the initial parameters, the underlying code of the physics engine. The laws of physics aren't just discoveries. They are the rules of the game we're living in, programmed into the system from the very beginning. The speed of light isn't just a cosmic curiosity. It could be the processing speed of the cosmic computer running our reality. This limit on speed would prevent information from traveling too fast, which could overload the system or cause glitches. Think about the sheer pace of our own technological advancement. In just a few decades, we've gone from simple games like Pong to creating vast photorealistic open worlds in video games and simulations for scientific research. We are already creating our own simple, simulated universes. What happens in another 100 years, or 1,000, or 1,000,000? If we follow this trajectory, it seems almost inevitable that our descendants, or any advanced civilization, will eventually have the computing power to simulate a universe as complex as our own. They could simulate consciousness, history, and the entire evolution of a cosmos. And if they can, Bostrom's argument suggests they probably will. Of course, the simulation hypothesis has its critics and its challenges. One major question is, what is the computer running on? If our universe is a simulation, it must exist on a substrate, a hard drive, in a reality outside our own. We can never access that base reality, so how could we ever prove we're inside a simulation? We are like characters in a video game who can never know about the console it's running on. This makes the theory potentially unfalsifiable, which is a problem for any scientific hypothesis. A good scientific theory must be testable. There must be an experiment we could perform that could prove it wrong. However, some physicists have proposed potential ways to test the idea. For example, they suggest looking for glitches in the matrix. If our reality is a simulation, it might not be perfect. There could be rounding errors in the laws of physics, or anomalies that don't fit our current understanding. One proposed test involves studying high-energy cosmic rays. If space-time is a discrete grid, as the simulation hypothesis might imply, then the most energetic particles should behave in slightly different ways than our current theories predict. So far, we haven't found any definitive proof, no telltale glitches. But the search continues. The very idea forces us to confront the limits of our knowledge and the fundamental nature of existence. Whether we are biological beings in a physical universe or informational patterns in a cosmic computer, our experiences, our thoughts, and our feelings are real to us. The simulation may be so perfect that it is indistinguishable from reality. Ultimately, the simulation hypothesis is a fascinating thought experiment that pushes the boundaries of science and philosophy. It makes us question everything we take for granted. From the nature of consciousness to the fabric of space-time, this theory reframes our entire understanding of the cosmos. Are we the product of random cosmic evolution, or the carefully crafted code of an unknown programmer? The answer remains one of the greatest mysteries of all. What do you think? Are we living in base reality, or is this all just an incredibly advanced game? For more mind-bending explorations of science and reality, make sure to subscribe to Facts Repo.